Okay, so what we're going to do over the next 2 days is we're going to learn about the other trig functions that are on your green sheet. Remember I talked about ones that we're not memorizing. So what we're going to do is we're going to learn how to use them to evaluate. Anyone remember what evaluate means in math?
Okay.
Yeah, typically with evaluating, you plug a number in and you say what it equals. Okay? So what we're going to do today is we're going to look at the sum and difference identities. We're going to learn how to evaluate them, so we're going to learn how to plug numbers into them and get answers. We're also going to look at how to use them in a proof, which is what you guys have been doing for the past 2 days. Okay? So we're going to do both types of things. All right? So at the top of your paper, we're going to go ahead and write sum and difference. And the first thing we're going to do in our notes is we're going to be evaluating. The second thing we're going to do in our notes is some proofs. Okay? All right, so the first example is to find the exact value. Find the exact value for sine of 23 pi 12ths. Find the exact value for sine of 23 pi 12ths. All right, and I should have told you to grab one already, but I didn't think about it. You do need a calculator. So what I'm going to do before we really get started is I'm going to plug this in my calculator. So what mode should my calculator be in if I'm trying to plug in sine 23 pi 12ths? Radians. Sine 23 pi 12ths. Okay, so I'm going to say this is approximately negative 0.259. Okay. Now they wanted me to evaluate this, so why am I not done right now? Why is this a problem? Because I just got an answer. No, it's the right answer. We just typed it in. It's literally the right answer. So why can't this just be our answer? It says exact.
So there should be no squiggly line.
It says exact, yeah. So when it says exact, we can't have decimals. We have to have like the radicals in there and stuff and the fractions, and it has to look all like crazy but be perfect because it's not rounded. Okay? So is this the answer? Yes. Is it the answer that we're looking for based on the instructions? No. But this is the answer. So what we're going to do is we're going to get in the habit of always writing the correct answer out so that at the very end we can check it and make sure the decimals match. Okay? All right, now what we're going to do here is we're going to look at these formulas. We're going to use the sum and difference formulas today, and this is a sign problem, so I'm going to focus on this formula right here. So let's go ahead and write it down. The formula that I'm going to use is sine of alpha plus or minus beta equals sine of alpha cos of beta plus minus cos of alpha sine of beta. Thank you, Ms. Rice, for not making me memorize these. You're welcome. Nope, you don't have to memorize them. I'll give them to you on the test. Okay. So the goal of this, to be able to do it by hand, is to find two angles that show up on the unit circle that add up to be 23 pi 12ths. Now that's going to be difficult in radians because most of us don't think in fractions very easily, right? We don't typically think in fractions very easily, okay? So what I'm going to do real quick is I'm going to convert this into degrees, because in degrees then I can think like, oh, 100 plus 150 is 250. That's what I wanted. Does that make sense? Okay, so how do I take 23 pi 12ths and convert it into degrees? So 23 12ths times 180 is 345. So we are finding sine of 345 degrees. Okay. So now we have to think about the unit circle. Do we have our unit circles out? Let's maybe get them out. We're going to think about our unit circle, and we're going to think of two numbers that either add or subtract to become 345. But they have to be angle measurements that are on the unit circle. So 345 is our goal. How are we going to get there?
300 plus 45.
300 plus 45. What's another option? Is there another way to get it? 270 plus 90 would be 360. 270 plus 75, but 75 is not on the unit circle. What about, I've got another one, hold on. What about 360 minus 15? Ooh. So this is sum and difference, so you could add or subtract to get there. Okay? What about, let me see. We could do sine of 120 plus 225. That one would work. Okay, so do you see how there's multiple options?
Yeah.
Okay. It doesn't matter which option you choose. You're going to come up with an answer that will work. Okay? The answers might look a little bit different depending on the option you chose, but your decimals will always match up and be correct. Okay? Yes?
If you start at subtracting, does that mean like the beta will always be negative?
If you start off, it doesn't mean the beta is negative. These are both always considered to be positive angles.
Okay.
If you start off subtracting, see how the minus is on the bottom? Then it means that you use minus over here in the formula. Since the plus is on top, if you use plus, then you're going to use the plus for this.
I was just talking about, like, for example, the 360 minus 15.
Yeah, you would call it...
Sine of being, would you do negative 15?
You would not.
Okay.
Yep. Okay. So which of those three do you guys want to do?
First one.
First one, let's do it. All right. So I'm going to say that this is sine of 300 times cos of 45. Since this is a plus, we're going to do the plus version. See how the plus is on top in both? So if you have a plus with sine, you have a plus over here, okay? Plus cos of 300 sine of 45. Okay? We good with that? All right. I'm going to go ahead and drop these down so that I don't think that these go with the other possibilities that I wrote. So if you look at your unit circle, sine of 300 is y coordinate 300.
300. That's what? And what?
Negative square root 3 over 2.
The y one?
Yep, the y coordinate at 300. Or 5 pi thirds. Okay. Cos at 45 or cos at pi fourths. Root 2 over 2. So these are written right next to each other, which means we're multiplying. So multiplied by root 2 over 2 plus cos of 300 positive 1/2 times sine of 45 root 2 over 2. If you're not used to looking for degree measures, then as soon as you knew it was 345, you could think of it instead as, what is that, 5 pi thirds plus pi fourths, and then you'd be good. Does that make sense? If you want to look for the radians because that's what you're used to, that's fine. Okay, so now when you multiply two fractions, how do you do that?
Straight across.
Yeah, multiply the tops, multiply the bottoms. So negative root 3 times positive root 2, negative root 6 over 2 times 2 is 4. So it is a common denominator, but when we're multiplying fractions, we still multiply the bottoms, okay? We don't say the common denominator is 2, therefore the bottom is 2. That works with adding and subtracting. When we multiply, we say multiply the bottoms. Plus 1 times root 2 over 2 times 2, 4. And so that means our answer, our exact answer, is negative root 6 plus root 2 over 4. Why did I not call that negative root 4?
Because it's different coefficients.
Yeah, it's the coefficients that you would be adding or subtracting. Root 6 and root 2 are not like terms. They're considered to be different. So you have a negative 1 root 6 and a positive 1 root 2. You have no like terms to add. Okay? Now, if we go ahead and type this in on our calculator, so I'm going to hit alpha y equals, so I can type in the fraction, negative square root 6 plus square root 2 divided by 4, and I get the decimal that matches up with that original problem. So I just evaluated it, but I have the exact answer this time. Okay? I just invented it. I thought of it. I'm basically the female version of Einstein in 2018. Thank you, and you're welcome. All right, example 2.
So on the test, right?
Yeah.
If we're using degrees, do we have to memorize the degrees too?
You do not. So I would say, yeah, in some ways for these, you kind of would have to know the degrees as well. Yeah.
I have just memorized it.
I know.
First test I memorized this. Second I memorized this.
All right. For this one, find the exact value
Oh, your voice is.
of cos of 13 pi 12ths. Find the exact value of cos 13 pi 12ths. Okay. So if you look at the cos formula, do you see how it's a little bit different than the other formula was? So we're going to go ahead and write it down so we can use it. We've got cos of alpha plus or minus beta equals cos alpha cos beta minus or plus. What does it mean that they switched it? It means that if you're doing the sum of angles here, then you use the minus, because that's on top. Does that make sense?
So you do the opposite.
You do the opposite. You do the opposite sign. So the sum and difference formula for sine says if you're adding, then you add. The sum and difference formula for cosine says if you're adding, then you subtract. Or if you're subtracting, then you add. You do the opposite sign. Okay? Cos alpha, cos beta, sine alpha, sine beta. It is a shorthand way of writing out one formula when you're really representing two of them. Okay? All right, so 13 pi 12ths. Can anyone come up with two fractions that add to be that? Or should we look at the degree measure? Let's look at the degree. Okay, so I'm going to do 13 12ths.
Well, you can do 12 pi over 12 plus.
Well, it'd be 1 pi plus 1/12, and that's not going to work, is it? Yeah. Okay. All right, 13 12ths. 180. Okay, so this is actually cos of 195 degrees. So what could we add or subtract to get to cos of 195 degrees? I heard 150. 150's not. Wait, 150's on there. 150 plus 45. That would work. What's another one that would work? What about 135 plus 60? What about 225? That's too big. 225 minus 30. Whew. Okay, so again, there's multiple options. There's not only one option, there's more than one. Which one do you guys want to do? The first one. Okay. All right, now, do you guys want to use the degree measures, or should we think about this in radians so it's easier for us to think about? Okay, 150 is 5 pi 6. 45 is 5 fourths. Okay, so we have cos of 5 pi 6, cos of pi fourths. It was a plus problem, so what are we going to use? Minus. Sine of 5 pi over 6, sine of pi over 4. Okay. So cos of 5 pi over 6. Negative root 3 over 2 times cos of pi over 4, root 2 over 2. All right. Minus sine of 5 pi over 6, 1/2, times sine of pi fourths, root 2 over 2. Now, it would just make sense that when we look at the unit circle, we have very repetitive answers, right? So when we look at these, we're still going to have very repetitive answers, okay? If you get something that's crazy different, you probably did it wrong. Does that make sense? Okay, so if we look at this, what fraction should we have when we multiply? Negative root 6 over 4 minus, we almost just did this, root 2 over 4, and that equals okay. All right, so negative root 6 minus root 2 over 4. Let's check our answer. Do you want to check cos of 13 pi 12ths or cos of 195? 13 pi 12ths? So both of them will give you the same answer. You just have to think about what mode your calculator's in. So if I'm in radians, okay, then I'm going to type in cos of 13 pi 12ths. Okay? And then I'm going to type in my fraction, negative square root 6 minus square root 2 over 4. What does that tell us? It's the same. We got it right. Okay. Yeah.
How does it say again which line it would be negative? Like how which
Yeah, so let's write this on our green sheet. Let's say right here, the signs match. So if it's a plus that you're doing, then it's going to be a plus here. So for the sine formula, I said signs match. For the cosine formula, I'm going to say signs are opposite. All right, can we see that? All right, we're about to do tangent. What do you see about tangent? It is more complicated. It is ugly. All right. Now, what do you guys notice about the signs for tangent? They match on top. You see that? They're opposite on bottom. Okay? So I'm going to say sine match on top, opposite on bottom. They match on top, they're opposites on the bottom. Okay. Now the tangent formula is a little bit more complicated, which kind of keeps in line with what we expect from tangent, right? It's always a little bit more complicated. Okay, let's do a tangent example. Okay, so we're going to say, for example, didn't write a tangent example. Find the exact value of tan five pi twelfths. Find the exact value of tan 5 pi twelfths. Okay, so I'm going to go ahead and write down the tan formula. That is tan of alpha plus or minus beta is tan of alpha plus or minus tan of beta divided by 1 minus or plus tan alpha tan beta. Yeah, it looks a lot more complicated. Okay. So 5 pi twelfths is 75? Okay. So if we do 5 twelfths multiplied by 180, we're going to get 75. Okay? So we got that. What numbers on the unit circle would add or subtract to be 75? 30 plus. All right.
Oh, 130 minus 60.
Wait, 130 minus.
Oh, wait, we don't have 130, my bad. That was my
Wait, 135 minus 60.
Oh, that's what I meant.
Is that?
Yeah. 135 minus 60. Okay. Let's go ahead and do this one right here. 135 minus 60. So that is going to be 3 pi fourths minus pi thirds. Okay. 3 pi fourths minus pi thirds. So that gives us tan of 3 pi fourths. We do the same sign on the top. So minus tan of pi thirds divided by 1 plus tan of 3 pi fourths times tan of pi thirds. Dang it, I wanted to do the more difficult one and I did the easier one. Well, you would rather see me do a more difficult one so that you can do the easy one. We might do this example twice so you guys can see both sides of it. Okay? Alright. So tan of 3 pi fourths, tan of pi thirds. Alright, what's tan of 3 pi fourths?
Root 2.
It's negative 1. Negative 1 minus. What is tan of pi thirds? Root 3. Root 3. Divided by 1 plus, and we already found those numbers. So it's 1 plus negative 1 times negative root 3. So what do we end up with on top? Negative 1 minus root 3. What do we end up with on bottom? That was negative times negative.
Why is the root 3 negative?
So that's negative times positive. So it's 1 minus root 3. Okay? Now technically that's not proper. Technically we should do what's called rationalize this, multiply by the conjugate. And then I talked to my friend who works in a college and she's like, why do you make them do that? We don't care. Let's just let them write that answer. And so I said, okay, that's easier for me to teach. So you're done. You're welcome.
What college does she work at?
She teaches at one of the Raleigh. I don't know the names of the community college. It's a community college in Raleigh. I don't remember which one.
Raleigh
All right.
Community College.
Is that a community?
Raleigh Tech.
Yeah, Raleigh. All right, so tan 5 pi 12ths. We're just going to double check our answer. -1 minus square root 3 over 1 minus square root 3. And we got it. Okay? All right. We're going to do that problem again. I want you guys to see the difficult problem with me so that when you see it again on your own, you're not like frustrated. Okay? Now, remember what I said about these problems being repetitive, right? When you do these problems on your own, you're going to see a lot of square root 6s and a lot of square root 2s. Okay? You're going to see a lot of those over 4. When you do tan, you're going to see a lot of square root 3s. Does that make sense? You're going to see a lot of these answers repetitively. Okay? If you're seeing a square root 17, you did something wrong. Okay? Because these answers all come from the unit circle, and we had certain numbers that showed up on the unit circle. Okay? So if you need to flip your paper over, you can flip it over. We're going to do the other one, the 30 plus 45. We're doing that version. So we're doing the same problem a second time because you guys need to see how to do a hard problem. So tan 30 plus 45. This one, I'm showing you the one that's as bad as it gets. Okay? This is the worst case scenario. Okay? So we're doing the same problem, we're just doing the worst case scenario version of it. So this is pi over 6, this is pi over 4. We're doing the plus version this time. Okay? So that means that if we follow the formula, we're going to have tan of pi over 6. And we do the same sign for the top. So plus tan pi over 4 divided by 1 minus, because we're doing the opposite sign this time, tan of pi over 6 times tan of pi over 4. Okay, that's the problem we're doing this time. All right, so tan of pi over 6 is root 3 over 3. Do you guys see why this one is going to be worse than the other one? Yeah. All right, plus what's tan of pi over 4? 1. It's just 1. Divided by 1 minus, and then we have tan of pi over 6, so that's root 3 over 3 times 1. Do we see how it's a little bit different than last time? So we have a fraction plus something that's not a fraction. What do I need to do? Common denominator. And what would the common denominator be? 3. Okay, so I'm going to take this one and I'm going to make it a 3 over 3. And I'm going to take this one and make that one a 3 over 3. Do you see what I did there? Okay. I'm sending this video to your mom. All right, so the top of this is going to be square root of 3 plus 3. See that? Square root of 3 plus 3. And it's going to have that common denominator because we added fractions. Are we okay with that? Okay. And then on the bottom, I'm going to have 3 minus square root of 3 over that common denominator of 3. And why was I allowed to ignore that 1? Multiplying by 1 didn't change anything. Awkward. All right. Now, we have a fraction over a fraction. Keep change flip. Keep change flip. All right. Keep change flip. 3's cancel. And so our final answer is square root of 3 plus 3
You can't have a square root
over 3 minus square root of 3. And we can't have the square root on the bottom, but Miss Rice's friend says in college they don't care. So we don't care either. So what we're going to do right here is we're just going to double check and make sure we still got that same answer. Okay, so do you see how this answer looked completely different from the other one? But it was right. Okay, so the only way for you to check your answers really is not to check my answer key, because what if you did it differently than me? The best way for you to check your answers on this is to check your decimals. Okay, does that make sense? All right, so when you're doing the sine and cosine problems, you're going to have a lot of square roots of 6 and a lot of square roots of 2 and a lot of fractions with a 4 on it. With the tangent problems, you're going to have a lot of 3's and square root of 3's and 1's. Does that make sense? Okay, and you've seen the worst case scenario, all right? And the answers are very repetitive, which means if you have your notes out when you go over these problems, you should be set. Okay? All right, the next part of our notes is the proof part. Okay, here's the proof. So we are going to add a strategy to our strategy list, and that is if you see one of the other formulas, a sum and difference formula, or tomorrow we'll talk about the double and half formulas. If you see one of those on a side, typically you work with that side.
It's what Saturday?
Monday. You guys we're so excited to tell her tomorrow.
Literally,
Saturday.
they were so excited.
They were just like waiting. Tomorrow's Saturday. So as I was saying, the next time I see you in class, typically you're going to work with that side. Now, I'd say that's true 70% of the time. So 30% of the time, it's not helpful to work with that side. It's just going to be, if you're working with the left side and it doesn't pan out for you, then try the right side. Okay? So this right here, I see sine of alpha plus beta. So I'm going to grab my green sheet, and I'm going to say sine of alpha plus beta is sine alpha cos beta, same sign, so plus cos alpha sine beta. So I'm going to take what's on top and I'm going to replace it with this. Okay? So take the top, and we're replacing it with sine alpha cos beta plus cos alpha sine beta divided by cos alpha cos beta. Okay. Now, this is the first time we've done proofs. We're not in crazy high college level math. We're still in high school math, which means that when I give you these types of problems, when they use these other 3 sets of formulas, I don't give you crazy difficult ones. This means if you can't solve it in like 3 or 4 steps, you're doing it wrong, okay? There are problems that would take a lot more steps, but I am not going to assign them to you, okay? Right. All right, so do you guys see how we have one term right here? This is one big term that's like kind of terrible looking. Do you see how this is 2 terms? Yeah. We want to split this fraction into 2 terms. So how do you split a fraction apart? Yeah.
You could do like the sine A cos B over cos A cos B plus f.
Yeah, so you can take the tops and split them apart, but the denominator has to go with each one. Okay, because it's a common denominator. So I'm going to write this as sine alpha cos beta over cos alpha cos beta plus cos alpha sine beta over cos alpha cos beta. It looks a lot worse than it is. You'll see it in a second, maybe. Yeah, there's some canceling. Anyone see the canceling?
Yeah.
The cos beta.
Okay, so cos beta on top, cos beta on bottom, right? Those cancel. What else?
The
Cos A, cos A.
The cos alphas. So we are left with sine alpha over cos alpha, which is tan alpha. And we have sine beta over cos beta, which is
And beta.
tan beta. Ooh, and we're done. Okay, so like I was saying, when I give you problems like these, I'm not going to give you ones that take a bunch of steps because that's beyond this class. There are people that would do it, but it's beyond the scope of what we need to learn in high school. Okay, so the ones that we're going to do, if you're struggling with it, just tell yourself it shouldn't be more than 3 or 4 steps. If it's more than that, I did it the complicated way. Maybe try working with the other side. Okay? All right. That is it for notes.